Okay, I'd like to begin by making sure you are with me. Would you please turn your iPads or device my way so I can see that you are on that slide? If you're not, then hurry up and get there. I have two people I'm waiting for. I'll catch them later. Right now, this first one, if I'm going to solve this, you have to know that there's logs on both sides, and do you know how you can handle that? If they have the same base, it's really pretty simple. You can take them out. It's that simple. You just have a little equation left of x equals 3x minus 2. It's that simple. Yeah, you can take logs out if there's the exact same log on both sides, same kind of base, then you can take them out. Now, would you please solve that? I have to be able to trust you can do basic algebra. Please solve that. Comes down to like x equals 7. It's not 7. Solve it. I'll pause for a second. We'll give that a try. All right. Zero equals 2x minus 2. Then you just add 2, divide by 2. Final answer, x equals 1. I wanted to show you a weird way you could solve this. If you can factor it, you should. And then guess what? X has to equal 1. See, either way, x equals 1. All right. So, what? Did you get that x equal to 1 at least? Did you solve it a different way and get x equals 1? Because that was the right answer. All right. Let's move on to the next one. The next one involves a rewrite. I'd say the number one strategy you need, because when you get stuck, you're like, oh, I don't know what to do. The answer is usually you should rewrite it into the other form. If it's an exponential, you should make a log. If it's a log and you're just stuck, it's probably time to rewrite it and make an exponential. All right. So, hint, make a log out of this. I'm going to pause for a second. Let me give that a try. So here's a good strategy. You figure out what the base should be by looking at the base over here. And oh, it's log base e. Some people will say, so you have to write ln. No, you can just say log base e. It does mean the same as ln. All right, then I hope you've learned that you don't just do them in order. Now you jump over to the other side and say 2. And then you jump back and then say 2x minus 1. Now right there, I'm going to drag this down into the open area here. A lot of people get this and they're like, okay, I don't know how to solve that. Well, the main point is, what are you solving for? Are you trying to get e alone? No, e's a number. Do you remember what e is? Usually there's like 4 kids that know what e is. Raise your hand if you're one of the kids that remembers e. All right, it's 2.718. 2.7 would be a good estimate. E's just a number. It's not a variable. Okay? If you haven't got that down, written it down, write it down. Get that down. E is 2.7. So whenever you see an e, don't think, oh, another variable to solve for. Oh, it's just a number. That means log base 2.718, blah, blah, blah. It's like pi, it goes on forever, never repeats. Okay. Anyway, that's what I'm solving for. Is x alone yet? No. You always start with adding or subtracting, and then you move on to multiplying and dividing until the x is finally alone. So you would start by adding 1, and I have log base e. I'm going to start writing ln. ln 2, and I'm adding 1 equals 2x, and then I want to divide by 2. If you have a calculator, you could do this, and I know you know that you could just type ln 2 plus 1. Just make sure you don't screw up the top is all one fraction or one part of a parenthesis. Think of it as like a big parenthesis around it. Final answer should come out to like 0.8 something. Does anybody have it? Can I round it to about 0.85? Okay. There you go. And there's my answer. X got a loan, and it's equal to 0.85. You need a calculator. Hint, the calculator, when we do this, the calculators are very handy, and I've only got 6 of them. Okay, so if there's 7 people that need a calculator, whoever's last to ask doesn't get one. So please, either A, if you know, like I don't own a calculator, I have no way to get one, then be here early so you get a calculator. Or B, borrow one from a friend or something. Okay, so have a calculator on test day, which is planned for Thursday with you having the escape hatch of, please let me take it on Friday during class. Okay? All right. Now, the last one is this one that you can still see on the screen here. To solve this, hint, you've done the kind where you squish them together. It's called condensing. Would you please condense the left side? I'm going to make a bold statement. You can't solve it unless you get it down to 1 log. So whenever you have 2 logs, the goal will be to make it into 1 log. Because when you're solving, there's no way to do it. At least I don't know how you could do it unless you get it down to 1 log. So to condense this thing to 1 log, I say it's log. And it never said a base, so what's the base? 10. If it doesn't say a base, it's 10. Of, what's in the argument here? X times 2x plus 1 is equal to 1. Oh, you caught me. I was assuming that this was add. I was just like thinking it was like all the problems that I had done on previous days. Sorry. It's a divide. You're right, because it's subtract. That's divide. Thank you for catching that. I actually did it right in the other hour. I'm like, wow, I'm doing it a better way this hour. No, I'm just doing it wrong. Okay, now I go 10 to the first equals that. Whenever you have a really strange looking problem, think rewrite. It's going from log form to exponential form, which means I'm down to just 10 to the power of 1, which I hope you know is just 10, equals x over 2x plus 1. Now, I have given you these dumb little sayings for a reason. 10 to the 1 is just 10. The dumb little saying in question here is it, can you factor it? You know, if you can't factor, you should. No. It's also clear all fractions. Like whenever you have a fraction in the problem, get rid of the fraction. How do you clear fractions? Yes? Multiply by the bottom. You shouldn't need me to do this for you. You should get used to, like, if there's a fraction, get rid of the fraction. I need a snappy saying for that. Like, if you can factor it, you should. If you can defraction it, you should. Taking out the fraction, right? So, okay. So we canceled this. And now I got 10 times 2x is 20x plus 10 times 1 is 10 is equal to x. And now you just have x's on both sides. Which one do you get rid of? The smaller one. You don't have to do it that way. It's just smarter. Because then you'll be left with a positive number. If I subtracted 20x right there, I'd have had a negative number left. So now I get a positive 19x plus 10. And some people are afraid of 0. It's just 0. Not a big deal. It's not like it's all different. I'm going to subtract 10. Final answer, 19x equals negative 10 divided by 19. X equals negative 10 19ths. Oh, wait. I know enough to watch out for negative answers. Do you? Let me go back up to the original problem. I just said that x should equal a negative number. But it's the argument. You can't have negative numbers there. Do you remember me saying one of the most complicated things in pre-calc is that we get answers and then they don't actually work? It happens all the time. We get an answer and then it's actually extraneous. You remember those? We've had them on tests multiple times. Yeah, like the extra finger guy. Yes, that story. So it looks like it works, but it doesn't actually work. Why? Because the answer came out negative, and if you put it back in the original, you will realize you have made a negative argument. And I remember her telling you, because she told me this, and I was like, okay, I barely understand what a bay is. But she said, like a love interest or something, isn't it? No? No, okay, now you're just messing with me. Anyways, so this stood for base, argument, and exponent. I know, I hope you know, there's all kinds of exponents. Aren't there negative exponents in the world? Yes. Aren't there fraction exponents? Yes. But these have rules. The base and the argument can't be negative, and they can't be zero. One more little thing that I don't think we're going to test you on, but I'll just tell you. The base also can't be 1. B cannot equal 1. You can't have a base of 1. Let me show you why. It's one of those little weird ones like nobody ever notices. Let's say I was going to do that. Wouldn't that mean 1 to the x power has to equal 5? And why is that a bad thing? Because it's impossible. Take 1, put it to a power, and make it equal 5. You can't. That's why you can't have 1 as a base. There's always somebody who will say, but can't you do log base 1 of 1? That's you. Okay. And yes, you can. But that's sort of like saying, can't you just say 2? You just take this and multiply it by that to get your answer? Well, okay, it works this time, but it won't work for any other power where you just multiply it this times this. That's a bad way to learn it. It's only it works on that one number. Because as soon as you move to 3 to the second, it's not 6, right? So you have to learn that there's exceptions to the rule. And yes, I get log base 1 of 1 seems like it would work because you can put 1 to the 1 power n equals 1. But I challenge you with this. Just because it works once and it won't work for any other numbers means that it's the exception to the rule. And the rule is, and this is even in the math books, bases aren't allowed to be 1. Okay? So anyway, that's just a small aside. What's really, really important is that you realize that I just got an answer that was a base or an argument that was negative. If that's negative, they're tricking you. That's not legal. If that's negative, they're tricking you. You can't have a negative base. Okay? Okay. So, I now have reviewed enough of logs. You know, okay, I don't feel like I have. I'm going to make sure that you get how to expand to log base 5 of x, y over r to the third. Nope. Yep, actually, yep. Okay, expand that all the way. Hint, you're going to have 3 logs instead of just 1. We did condensing already. Let's do an expand. You're expanding this. The math behind the parachute thing is actually, there's not much math in this one. It was just the moral of the story. So, yeah, I'll show you the rest of the video. Sure. But finish this up. Okay, hint. Log base 5, and then there's another log base 5, and there's another log base 5. I can spread it out, okay? Do you get that the multiplies become adds? Are you with me so far? And the divided by is subtract. And I'd have to mark off 5% on this person because it's not expanded all the way. What's the dumb little thing that's left? Yes. You got it. That's supposed to be there. I know some of you would have gotten the 5% off deal because you didn't notice that. Is it really expanded more? Yes. Technically, do you have to do that? Yes. If you want full credit, yes. Could I give you partial credit? Yes, if everything else was perfect. Having that 1, 3, I even agree that it's kind of lame, that's considered more expanded, but it is. But now you know. You've been warned. Yes? You can, but let me show you something. It would be minus log base 3 of r minus another log base 3 of r minus another log base 3 of r. But what does that all add up to? Negative 3 log base 5 of r. Oh, I said 3s every time. I'm at 5s. I get what you're saying. But the directions are expand and simplify. I never said that. You're right. But on all your worksheets and on the test, it's going to say expand and simplify. But otherwise, you had me. You're right. If it was just about expanding, well, then you could also, like, if you want to really make it bigger, say, oh, isn't 1 times x the same thing as x? And then can't I split that apart into log base 5 of 1 plus log base 5 of x? So, and then you couldn't I say it's times 1 again? And then I could just, okay, so yeah, it's got to be the simplify part, otherwise people do that. Good question. Because there's 2 parts and only 1 part being subtracted, I don't need parentheses on this one. But do you get if there had been a minus here that was supposed to be extended over both of them, then I would have needed a parenthesis on that? I know it's kind of weird. It's kind of like this. Let's say I had this as opposed to, then there's a chance that I would need to have that parenthesis to distribute the negative out. Whereas, do I have any reason I would need a parenthesis on the top one? No. There's no chance that that could get messed up, where the bottom one could. Okay, so moral of the story, because the minus was near the end, I did not need a parenthesis. If you really feel better about it, put a parenthesis right there. But it won't change anything. That is not what I said. If it's at the end, then you wouldn't need parentheses. All right, so hold on. I got to give you a problem then. You're pushing me on it, which I understand, and it's a good question. Now, XRMP. I'd have to split this up into log base 5 of x plus log base 5 of r. Do you get how I did the top? On this one, I would need parentheses because I'm subtracting these 2 things, and that negative needs to get distributed. So the question really comes down to if there's 2 things on the bottom, then you would need parentheses, like this. And that way, this negative will get distributed to both of them. You know what I'm saying?
Yeah, but then the problem is you have to put around
You're right. That would have been a problem. What I said is you could put parentheses here. Actually, wait a minute. Actually, if I put parentheses here, it wouldn't have hurt anything. Oh, okay. You could put parentheses there, but do you get, it's a problem. I can't just say, you can do anything you want with parentheses. No, that's not. There are a lot of things where you could put parentheses in and it wouldn't hurt. But there's other times where if you leave off the parentheses, it's a big deal. Yes?
Would it be okay to just subtract both of them instead of, like, on the next problem you did? And you just put a negative instead of positive at the end?
If you didn't have the parentheses, but you had a negative on both parts, this and that, then it's like you just distributed the negative, so it's fine. All right, I need to get to a certain kind of problem. It's right here. Uninhibited growth. It's got the mega bunnies. This apparently was a thing in Europe for a while. People were into giant bunnies. Like people would wear bunny masks. Can you imagine? You're like staying home. Your parents have gone out to have some fun and you're home alone and you look out in the backyard and there's a guy standing there with a bunny mask. Or that guy. Do you need somebody?
Hey, could I talk to Hunter real quick?
You may. All right. So I had a friend one time. He was staying home. I knew he was home alone, and I called him up on the phone and I said, "Are you alone?" he I then hung up and then called him back and he said he was scared out of his mind. He had no idea that like somebody knew he was alone. And anyway, so okay, enough of that. So if 14 goes up to 44 over 3 years, that sounds like exponential growth to me. So let me show you how you could make an equation out of this. This is your equation, and don't let n of t fool you. It's a lot like just like f of x, which is a lot like just y. That's just a variable in front. And I want you to write end above it, because that's your ending value. Hint, in this case, 44 bunnies at the end of the experiment. Okay? N sub 0 is kind of like our starting height. Do you remember the sub 0 was like the one that was your initial height kind of thing? Well, this is our starting number. That was end, this is start. Then E, which we've already discussed, is 2.7. Then there's K times T. K is the weirdest thing. K is just a constant. And then T is the time, gentlemen. I need your attention. All right. So T is time. And K is a constant. I'm going to give you an example of one of these right now. What position did I say that was in? Stay with me. I know it's hard to concentrate, but we got to get all the way through the end of the hour. You can do this. That's the starting value. Started with 28. And instead of E, I put a 2. You could use, sometimes they'll give you 2. Sometimes they'll give you E. Why do you think 2 is used a lot? Because it has to do with half-life or doubling. You've heard of things doubling before, right? You know, the old problem with a grain of rice, and you double it, double it, double it, and all of a sudden it's like this huge amount. Yeah, doubling is a classic example of exponential. And the other thing we use is E sometimes there, but I'm using a 2 this time. And I'm using it because I wanted to put it to the negative 1. Do you get that 2 to the negative 1 is the same as 1/2? 2 to the negative 1 is the same as 1/2. So this is exactly the same as if I had written this. That's important for you to understand. You're remembering that 2 to the negative 1 is 1/2? Does that make sense? Okay, now do you get that this problem must be about not growth? It's not doubling. Because I put a negative 1 there, it actually means that this is a half and it's actually decay. That's called exponential decay. So if this number is negative 1, that means you flip this and you will have something that is decay. All right. So when I look at this, I can say, oh, so you start with 28. It's got a decay rate of, it cuts in half. And then the question just becomes how much time do you want to give it? If it cuts in half every hour and you do it for 10 hours, do you get it's going to be a very small amount at the end? Cuts in half from 28 to 14 and then to 7 and then to half of 7, which is 3.5, and then half, it gets really small. Okay. All right, so here's a typical question. I want you to go to this one. Radioactive decay. Half-life. Have you heard of half-life? Well, now you do math with half-life, right? So, down to 12 minutes. Unfortunately, I got to teach right through the end. The plus side of that is when Mrs. P comes, she will be able to just review with you for 2 straight days. There shouldn't be much. There might be things you had only seen once, you know, and she'll be reviewing it, but it still might feel new. But there's just going to be practice problems for the test for the next couple days. All right. Okay. All right, so this problem, that's where the end goes. That's where the start is. E is a number. It's not a variable, so that's fixed. It's 2.718. K, it just says here, is less than 0, so therefore it is radioactive decay. I was just explaining that if the K here is a negative, that means you've got decay going on. All right, so here's a typical question. Iodine-131 is commonly used as a radioactive isotope, uses to help to just see how well the thyroid is functioning. So the decay of this follows the model given in equation that the half-life of iodine is 8 days. Whew! Half-life of iodine is 8 days. If you have 5 grams, hint, to start with, initially, find a function that gives the amount T days later. That means they want T left in the equation. All right, here's what you do. Do you have your starting amount? If so, we will put it there. Do we have our starting amount? Yeah, we have a 5 for the starting amount. Do we have how much we will have at the end? Did they ever tell us that? No, they did not. So I'm going to put just an A of T for that. Okay, so A of T equals 5 e to the k T. But I know a little bit more than that. What if they also told me that I haven't used yet? The half-life is 8 days. All right, so watch what happens here. If the half-life is 8 days, that means I start with 5. What do you think I end with if it's half-life? No, it's half. It's not 0 life. Half of 5, 2.5, equals 5 e to the k. And how long does it take to do that? Times 8. If you do that and you solve for k, you can find out what k has to be. Okay? You could solve that for k? All right, let me help you solve it for k. That's your first job, is to solve that for k. I put in half of it here. I started with 5. All right, so now I'm going to go divide by 5, and who knew 2.5 over 5? It'd be 1/2 equals e to the k times 8. I'm trying to solve for k. Hint, whenever it gets really weird, what did I say would be the main way, the main system? Yes, you switch forms. You rewrite it into the other form. So that needs to switch to log form. Log base, what's the base here? E, just E. The 5's already gone. I divided by 5 on both sides. Okay. Log base E of, jump over here, 1/2 equals 8k, or k8, doesn't matter. Now, you will have a calculator for this test because there's a lot of word problems on it that need a calculator, okay? So you'd be able to use a button. Please don't tell me you'd do the log E button because there isn't one. What is the log E button? ln. So you go ln 1/2. Come back with me. You got too warm. You got too tired. ln 1/2. Use a calculator. Would you tell me what it is, please? ln 1/2. ln 0.5. Thank you. And then divide both sides by? Divide by 8. K equals some negative weird decimal. What is it? Did you get it?
Yeah.
Negative 0.086. There it is. Now, I've figured out what K was, but I'm not done. I got to write this equation over again with A of T is equal to 5e to the negative 0.08 t. There. I've written an equation that has t in it. It asked for t to be in the equation. See, it's got a t in it. And I don't know how much it is because they didn't tell me how much time. All right, that's a half-life question. She's going to do more of those with you. All right. Now I'm going to do one that is similar to that, but different. I'm going to go back a notch. There was another one up here. The bunnies question. All right. Do I know the starting amount? Oh, yeah. It tells me 14. So I'll put a 14 here. Do I know the ending amount? I do. It's 44. I put that there. Do I know the K or do I know the T? The T. How long was the amount of time? See, there's 3 years had elapsed. So T is 3. Do you think you could solve it for K again? That's usually what these problems are about, is solving for K. Would you please try this one now? 44 equals 14 e to the 3k. Hint, start by dividing by 14. Then rewrite it into a log. I know this is intense, but if you can stay with me for the last minute here, I'll show you what your homework is. There's just 2 homework questions that are like this. Can't find my calculator. Help me out. Somebody, what's 44 divided by 14? 3 point what? Well, that's weird. That did not, what is not what I was expecting. E to the 3k. Okay, then I'm going to rewrite ln. That means log base e. I'm just going to write log base e. Too many kids get confused by that. Of 3.14 equals 3k. Is k alone yet? Nope. I'm getting close though. If some nice person would tell me what ln of 3.14 is, and is that before you divided by 3? Excellent. Then I'm going to divide by 3. Final answer is whatever 1.15 divided by 3 is. 3.8. Thank you very much. There, I found K. Am I done? Not really. I got to go back up and put that 0.38 in for K. So here's my equation for my mega bunnies. We start with 14. We put it to the E to the K, which I just figured out. What was it again? Point what? 0.38. And then T. There. That's the equation that tells you any number of mega bunnies. Do you get it? Boils down to finding K. That's what it boils down to. You stick in the numbers and you solve for K. All right, one more thing I got to tell you about half-life. Sometimes they will just tell you, hey, by the way, the half-life on this stuff is 8 days. Watch how fast you can write the equation. If they say I had like 10 grams, and the half-life, if I use a 2, do you get a 2 to the negative 1 would mean half-life. And if I said it's going to be 8 days, I take t, and I'm not going to stick in an 8. I'm going to say divided by 8. Why? Because in 8 days, you want it to be a half-life. Do you get if I put in an 8 under time? This becomes a 1. And then this just becomes 1/2. And it goes half of 10 is 5. And isn't that what we want to happen? We want to get 5. in 8 days. So let me do that one more time. Here's your base formula for half-life. Anytime you want to do half-life, use a 2 because you want it to be to the -1, which makes it 1/2 power. And then we need to get the time to be divided by whatever the half-life is. What if I said instead of 8 days, I said it was 2 weeks? I'd say divided by 2, and then I'd say it was in weeks. What if the half-life was 72 hours? I go like this, divided by 72, and it's in hours. All right, she will practice those with you. Half-life questions. Solving for K. Thank you. Your homework is the first 2 pages. Wait. Okay, good. You were heading for the door pretty fast, so I had to make sure. All right, just so I know, pay attention. Got to tell people what the homework is. There's 2 pages of homework. Right there is where it starts. See the little gingerbread man from Shrek? That's a question, and it's about half-life. See? And I just told you, if it says half-life is 5.27 years, you're going to put that up in the power. And then this page. Those 2 pages. There's 2 problems, the first 2 problems. That's all I'm assigning. Please check the answer key to understand these as well as you can. That's all I have for you for today.